So, according to the syllabus, I think it is officially a recap reboot day. The next project is actually due the 22nd, but I was hoping, or I am hoping, on having a, sort of before that, a bit of a developer release demo, earlier opportunity, encourage people to sort of release things, a playable demo in advance of that, probably just going ahead putting that on itch so that they can get feedback before the final submission of the project, right? So that potentially other people can play it, you can see what it looks like on other people's computers, other people in the class. The goal would be to have at least, that you'd have to sort of convince at least one other person in class, or maybe it could be a friend outside the class, something like that, to play your game, to try it, to give you feedback, publish it, put the link up there so I could see it as well. So if there's any major issues, we can kind of catch them. Anything that like, works fine on my machine, but it works, it doesn't work on somebody else's machine. But also, so if it's like, turns out that, you've tried it so many times, you've played it so many times now that, you take it for granted that it works a certain way, or it's obvious that you need to go into this corner of the screen and click on this thing and so on. So to help find out that maybe those things aren't so obvious, or maybe there's good reasons to, everybody does play testing at some point. Any kind of a game that gets released is going to get play tested somehow. QA is a huge thing. I've seen lots of people in the game industry who got their starts by being QA people, quality assurance testers at the big game companies, then went on to become producers or programmers or artists and so on. It's a great way to kind of really get a feeling for what other people are doing and how people really react to your games and your designs and so on. So we want to have something in advance of the final version. Whether or not we stick precisely to those dates, we'll see, but we'll go for it. So we'll try to have that next week. Technique-wise, we're going to have sort of a simple day today. I wanted to discuss, so the main stuff is to go through, and I think I put this on here. Yeah. Tile maps. We kind of skipped over those real quick before to kind of get all the AI and get some thoughts about what your games might be. Hopefully you've been giving your games some thoughts in terms of what type of top-down game do you want to do? Is it a asteroids type thing? Is it a space shooter, top-down space shooter? Is it a RPG style game? Is it a roguelike game? Is it a JRPG, Pokemon clone? Bullet hell, whatever. Hopefully you think about that. Should be sprite-based, as usual, for our 2D stuff. And one of the big things that we can do in support of that to make the game all that much more interesting and rich and so on is start to use like tile maps. Right? Tile maps are commonly used. They'll be used probably in both this project and the final project make a lot of sense, especially as you get into platform game design and so on. Use of tile maps can really give you a big boost in terms of bang for the buck in terms of your graphics, and also using them as a design tool for your level design and so on. Right? So first, just a word from today's sponsor, Packages. If you are in need of moving things from project to project, packages are a great way to do that without upsetting all of the Unity team collaboration, team server, all that kind of great stuff. If you need to save a project, or you want to import something, or you used something in a previous project that you want to move over to one other one, hopefully, I think the vast majority of you have been doing fine with regards to reusing the same project and keeping the submissions through there. So it's not much of a problem this semester, as it's sometimes been in the past before. But if you do need to create a package, use assets export package. We'll go through the process necessarily. So back to the main program today. So tile maps. Tile maps are a great way, like I said, to get lots and lots of bang for the buck from artwork in your game, especially if you design your tile maps in such a way that you can use things over and use them seamlessly and connect them and kind of get a lot of use out of them. So the idea is that basically, rather than creating screens full of unique pixels, like, imagine if you had to say to yourself, well, my world in my game, the background is, a lot more than 640 by 480 these days. It's a 1920 by 1080 game, imagine. So that's like 2 megapixels. So imagine you had to then design, your background, and maybe, there are certainly games that do, have unique backgrounds and everything, every pixel is drawn uniquely, and so it takes much more of a sort of background artist to create things. But with tile maps, rather than creating screens full of unique pixels, we divide our world into basically 2D tiles. Think of them as chunks or blocks if you were thinking in 3D. Cubes, they could be. Usually they're squares. They don't have to be square, actually. They can also be isohedrons, so you can do things like look at, maybe you have a 2.5D or some kind of different view in 2D. But generally, for starters, we'll talk about these 2x2 tiles that are then sort of designed and they wind up populating the screen. So imagine, like in this case here, we have what looks like we have basically some sort of part of the map that we have the water, we have a shoreline, we have what looks like a little bay, perhaps, and going into a little river kind of thing here. So here's maybe it's an ocean or a large body of water. And then we have the shoreline, and we have a green, grassy area around the river and kind of most on the shoreline here. But then we have, so we have green, then we have more lush grass, these sections here that have a little 3. And then 2, there's an actual tile with a tree on it, right? So we have lots and lots of area. We can look at this map here, this terrain, and make kind of sense out of it. And the idea is that you don't have to necessarily paint, I don't know how many dozens of trees there are. We're not creating lots and lots of unique trees or even unique little tiles of water and so on. You could do something like just basically create a single tile that represented a tree, and a single tile that represented some grass and maybe just a green area and so on, and then reuse them over and over again. And you have some sort of map in memory in your engine that then refers to those individual tiles and then can populate the world with them. So basically you create, in this case we have a real simple tile map that just has 4 potential tiles in it, and then you use an index to say what's within each location, right? So I think this is it 16 by 16? I forget how many. 2, 4, 6, 8, 10, 12, 14, 16. Okay, so in that 256 tile or 256 element array there, it's kind of a 2 by 2 array, 16 by 16. Instead of having 256 unique things, we have basically references to one of 4 things for every kind of block on there, every tile on there. So the nice thing is that the world doesn't necessarily look chunky, even though our little example here might feel pretty chunky because it's just solid colors and so on. But the world doesn't necessarily look chunky because the game engine instantiates all the detail in each tile at that location. A tile doesn't have to be something as simple as an 8 by 8 block of pixels even. It could be a very complex thing. It could be highly detailed. That may even be, imagine the meta case where we said, well, each one of those things is actually a 256 by 256 pixel texture, or maybe even a 4K by 4K texture, or some sort of world element. So maybe it is just a highly detailed version, but you might just have 4 sections, each with its own detailed thing. So the world itself, it doesn't necessarily have to look pixelated and chunky. It's just a matter really of saying, okay, there are regions there in the world that kind of are used over and over again, or types of regions that get used over and over again to create our sort of terrain in our map, right? General idea like that. So in practical use in our game here for now, we're going to say that each tile in our world is basically referring to a sprite, right? So each tile is a some size. It's not a fixed size. Like here, we have 48 pixels per unit, so each tile is 48 by 48 potentially. We import that and we organize that as a tile palette. So to organize that, we need some sort of structure to store and retrieve those sprites from an in. We need some structure to store and retrieve those sprites in. Well, that sentence just is really reading awfully weird for me today. In an orderly fashion, to store and retrieve those sprites from in an orderly fashion. Anyway, okay. So we have a special 2D tool in Unity called a tile palette. They're collections of sprites referenced by an index within a grid, allowing for very efficient reuse. They can be painted, filled, erased, moved, just sort of like a simple paint program, allowing for very easy level design. So let's sort of take a quick look at that. So I think I have Unity running here. And where is it? No, I don't. I closed it down. All right, let's open it up again. And I have to sign in under my other account again. Sorry, just a moment. Heard of at least one person accidentally typing in their password during some kind of Zoom call or something like that without it hidden and all that. Oh, imagine that. Letting the whole world know you sign on to Unity. Or, well, some other Google had to immediately go and change all their passwords. So while this is loading, has everyone seen GitHub Copilot yet?
Oh, is that the thing where it autocompletes?
Yeah. I saw that for the first time over the weekend, and it's so much more than just auto-completing. Like you can just you tell it, or you begin to type, I need an algorithm to do a depth first search. It just boom, like does it. It's basically they've married AI to all of the public code in GitHub, and it's code completion on steroids, so you can ask it for all sorts of things, and it does an amazing job, which is a nightmare for, of course, things like, computer science homework, where if you want to just implement this algorithm, it will do it for you. It'll give you 10 or as many different variations on it as you like as well. So it's going to be sort of a game changer, I think, if there ever was one in computer science education, as well as in the industry in general. Because suddenly your ability to memorize every possible algorithm out there and code them immediately, you can really just smoke coding interview tests now, because you can just start to type code in there and it'll just auto-complete it all for you. So I don't know how the industry. Anyway, that's just my interesting CS topic of the day. We're going to have to figure out how we're going to deal with GitHub Copilot. So anyway, this opened a lot faster than I thought it would. Now I've already, in my little project here, I've started using tile maps, and you can see it already. The world that I'm in here with my little tanks and so on already looks far cooler, because it has a border and just background. It's not doing anything right now. It's just totally for looks. So the tanks are still just wandering around, shooting at the little apple. Every so often, I can, still click on that, scare them away, and so on. But the nice thing is that it looks like they're in a world now. They have this real space. They're sort of in some kind of room, and we see some exits or entrances, and it starts to really feel like something. And this consists of a relatively small number of tiles that then I painted in to create this scene. So the basic idea is I happen to already have, and you can go to the Unity Asset Store and pick up various tile maps if you like, or create your own. But I happen to use one called, yeah, I'm going to forget the name of it now. Well, let's see, RF Castle. And if you want to use that one, by all means, you can. If you want to get creative, find another one, by all means do that. But this one, where is it now? Yeah, Rogue Fantasy Castle. And this has a collection of kind of 2D art that are more sprites, as well as a set of tile map oriented backgrounds. So I've already purchased this from the store. I think it's a free asset, and I've already imported it into my project. So the main thing is that it shows up in here in RF Castle. I'm going to look mostly at, there are two already pre-sliced, well, there are pre-sliced versions, but I guess we look at the non-pre-sliced ones as well. There's a sprite sheet over here, which is all these different elements in it, which is our tile map. And then also there's a sprite sheet of decorative elements, which could also be used as tile maps if we wanted to, but they're more designed towards like placing them in a scene. Like they're not, there's various curtains and urns and rocks and things. You could use those in a tile map as well, but let's look at the main level build stuff. Now, some packages will come to you pre-sliced. So if I click on here and I open this directory, you'll see that they've already created a sliced version of the tile map for me. And they've already, they basically have it in little blocks, or they've gone through the process, I should say, of setting up the import for the Unity inspector so that it knows the proper parameters, that it is multiple sprites, that they are 16 by 16, and so on, right? So it just really tells it a sliced sprite sheet is really just one that has its import settings set accordingly, right? And we have the same thing sort of in the decorative area, and you can use these parts again. There's curtains, and what else do we have? Some rocks and things. Candelabras, all kinds of neat stuff. Now, if you didn't have it pre-sliced, let's see, we'll go back to RF Castle, and say you just had something like this, you have to go through the process of slicing it, which is an awful lot like setting up a tile map, a sprite. So, let's see here. And in this case, we would go and say, well, it's going to be multiple sprites within there, not a single one. And 16 pixels per unit happens to be how this is designed. And I could go into the sprite editor, apply. And now it's a matter of saying, well, all right, how are things going to be divided up? So I'd have to slice things, and in this case, I might want to go according to cell size, and let's tell it it's 16 by 16, for example. Okay. And this would do a reasonable version, right, of dividing things up. So you can see it's some of these things do have a bit of overhangs and whatnot that really aren't super amenable to being divided up too much, but they work out okay. So we've sliced that up, and we can say apply. And let it think for a moment. All right. Go ahead and close that. So now you can see in here, it is also, instead of that single sheet now I have these individual chunks that I can refer to. Now, you don't just drag a chunk like this and drag it into your scene. Right? You could use it just like a sprite. I could just drop it there, just like the apple or anything like that. I could go ahead and do that. But that's not really a tile map. That's just using that as a single sprite. So to create a tile palette and a tile map, I have a few more steps. Right? The first being we need to create a tile palette from our images there. Now, I happen to already have one set up here, and I'll show you the process of setting up another. You can have any number of tile palettes that you like, and you can use them, mix and match them. So we're going to create, say, a new one here. I can click down here. You see this one was called RF Castle, and I'll go ahead and create a new tile palette. And we'll call this second castle, just because. Rectangular grid, you see, it could be a hexagon, could be isometric, so on, but we're just going to do a rectangle, automatic size, and say create. Once I do that, it's going to ask me for a directory to put my palette in, so I'm going to create a directory in assets. I just created one called tile maps. We'll put things in there. Or, well, just to not blow anything up, I'll make this one tile maps 2. Tile maps 2, select that folder, and it creates a blank tile palette for me. Then to put things into that tile palette, I can just go and I'll say, well, I'll drag this whole thing in here. You'll see it's dropping that in for the moment. It's going to use that to tell it to put it in that directory that I just made. Space for it again. And it's basically creating all the metadata for each one of those tiles in there. Right? It will go so far automatically to also do things like create some physics shapes and colliders and stuff, so that as you use your tiles, it's not just a matter of having a simple image for them. You can have other things. It knows, where's the center of these tiles, where is the boundaries if you're using them, say, in your environment, and you want certain things to really be walls versus just backgrounds and so on. Collision shapes or physics shapes can come in really, really handy for that sort of thing. So that's where it's kind of putting all of that information that it's going to generate for each one of those. And this will take a moment. Come on, Unity. Interesting if we eventually get AI to the point of being able to say, like, oh, design me an apple picker game, and it'll, it would know, go out there, look for all the apple pickers and figure out, what rules. And then it's just a matter, well, I want an apple picker game based on dropping boulders from wherever, and find the right assets and put us all out of work. Well, someone will always have to figure out the applications. I think ultimately that's, one of the most important pieces is defining what the applications that we're interested in pursuing and building are. And then higher level architecture is probably going to continue to be probably a human task, but a lot of the lower level stuff should be pretty interesting for people who are doing like indie and solo game projects. I think that would be one really cool thing. Now suddenly you can do the work of 10 programmers because you'll just have the entirety of the wisdom of GitHub at your fingertips. I don't know how much Unity code there is on there, but.
How exactly did you set I'm trying to set the tile palette there.
Mm-hmm.
I made one. I have the assets. I just dragged it in, but I just did this. I have a palette here. What do I do with that?
Oh, where is that?
Like in the palette. So like I clicked this and I just made it with it was empty.
Create.
It's not a palette, right? But like when I make it like this, it's like empty. There's nothing here.
Okay. Click on Open Tile Palette. And that would normally be where I'd be dragging this stuff in.
Oh, you bring this in here.
Yeah.
Got it.
Yeah.
Thank you.
I'm not sure what that other blue screen that you're referencing there. It looks like it might be. It looks like it's creating a tile map there instead of the palette, which is odd. Yeah. So once you have the tile palette here, then we'll go and I'm going to create an empty scene. So the scene's over here, and we'll just create a scene, and we'll call this castle. Fix that typo. All right. So to start using it, this is where two monitors come in real handy. So to start using it, we need to create a map to start dropping things into. So we can right-click over here and create a 2D object called a tile map, a rectangular tile map. All right. Now it's actually going to create a few things for us. It creates a grid, which lets us know what sort of what our boundaries are, what where things are. Let's see. Put that. Where can I put that? Down there. So we have a grid, which is really just telling us, you know, the alignment of everything, how the tile map is going to be aligned. So we have a cell size 1 by 1. No gaps in between our cells. It's a rectangular layout, and it's XYZ swizzled in terms of how it's laid out. Usually just leave most of those alone for the most part. And the important part is that we then have the tile map underneath there, which is really what's in charge of rendering out the tile map. So now you'll see we have things like the tile map renderer, the tile map component itself, and let's see, well, that's just all additional settings of the tile map renderer, right? So once we have that, now we can actually start painting things in. And I guess I'll just pull this one out again. That's going to be a pain. There we go. Whoa. All right. So we'll say, the way I did the other one is I basically said, all right, I grabbed this top part of the world, and you can grab any number of tiles that you want and start painting them in. So I went ahead and say painted that there. And you can also rotate the tiles. So it's handy to be able to say rotate, and then you have things on the bottom here. And we could even go so far. Rotate this one, put it on the side, and then we can say grab some cross section here, and use that. And this is one of those weird situations where the bottom of the actual tile map doesn't quite match the top. So this is one of the situations to say, I'll go ahead and grab the top and then spin it around, and it'll fit nicer in the bottom there. Yeah. So whether you have 4 tiles, 1 for each corner, or you just go ahead and say rotate the corner, you can get even fancier in terms of your reuse. Like if you wanted to only have 1 corner and reuse that over and over and over again, you know, taking to heart the whole, you know, tile reuse thing. Really good that way. So then we could do, from here we could start saying, well, I want to have, say, here's my entries and exits. Start getting interesting. And you can even do things like drag areas, so you can kind of fill in whole sections with the same tile over and over and over again if you like. Right. So that's just creating a whole kind of background, and it's kind of the basic use of a tile map. What gets a lot more interesting is when you start to use tile maps that are things like, well, let's define the walls as a particular tile map, and the floor as a different tile map, and obstacles as certain types of tile maps. And then you can have different types of reaction, or different types of interactions, excuse me, with those tile maps. Right? You might want to leave, the player can move around freely in the middle, or enemies can move around freely in the middle, but they can't see beyond this wall. Right? So to do that, I'll go ahead and save this scene and jump back over to my other one since they're already, whoops. My enemies are already kind of there. Now this just has a generic background here where everything is just kind of its own thing. So that's why when I press play, nothing collides with anything just yet. It just, everybody just wanders all over them. But what if instead I said, well, to make this easier to deal with, I'm going to start off by erasing everything inside here. Maybe that. Right. All right. Now, there's nothing inside there, but I would like to have my grid there. I mean, not my grid, my background there. So I can have multiple tile maps. Here I have my first tile map, and I'll call this one walls. And I could then just create another one, 2D object tile map, rectangular. And I'll call this one just background, or it could be called floor. All right. Make sure to choose that one. Which one do I want to see? Let's see. I'll see the tile map. You see it's kind of highlighted. That's the one I'm on here. So I'm going to go ahead and kind of paint in my floor here. Make sure here. This thing, the active tile map. Floor. That's the one. All right. So I'll have that. And now when I see it all together, it looks like it's all one, but this is the floor and this is the walls. Right. And now the interesting part is really to say, well, the walls, I'm going to add a component. And the component I'm going to add is a tile map collider 2D. So you'll see that it has put colliders around all of my tiles there. And I'm going to go one step further, and I'm going to put a composite collider 2D there on that. And we'll tell this one is used by the composite. So it will kind of simplify my colliders to be just this area here, right? So now the nice thing is I'm going to go ahead and move my tanks and things here. Make sure none of them are already sort of pre-collided with anything. That would be bad. Whoops. let's see if they're smart enough to, well, things are getting a little bit wacky. Now, the reason for that is that by default, when you create a composite collider, it creates a rigid body for you automatically for whatever the object is that was on. So that whole background was doing all sorts of gymnastics in there. We got to fix that. So if we go back to our grid walls, you'll see here it added that rigid body 2D the moment we added that composite. So we can go ahead and call that, say, static. And now it should stop bouncing all over the place. All right. And now our tanks will kind of collide potentially with that. The bullets collide, and so on and so on. All right. So we could go further, and we'll come back here and we'll edit our walls again. Open our tile palette, edit the walls. I'm going to grab my, whoops, we can play. Grab my eraser, smaller here, and tile map, walls, eraser. Oh, I'm going to erase these areas here. Now, I didn't do that good of a job because, well, I'm going to open up some of these to make them bigger here. See, I'll open that whole section, right? And then I will go to my floor, and I'll fill in the floor here. So then I'll go back to say none. And you'll see that my composite collider has been adjusted now. And let's see if any of my enemies will be smart enough to wander into that area now. Well, you see the bullets are shooting it there. That's convincing enough, right? Now, there's still an edge collider around the whole screen so that everything kind of will wander around. So if you want to automatically generate a maze, or not automatically, but if you want to have a maze with all the proper boundaries and all that kind of stuff, a tile map is pretty helpful for doing that sort of thing. So the one other interesting thing about tile maps, or of many interesting things about tile maps, I suppose, is that they act like any other object inside Unity, any 2D object. You notice when I first used the composite collider, it generated a rigid body and it was bouncing around and moving and so on. You can have moving tile maps. You can put scripts on tile maps. You can even do things in some more advanced ones. There are animated tile maps and so on. So we'll stick to more or less the basics for now. But you could do things like have whole sections that open themselves up, or things that you bump into that cause a trigger zone or some kind of things like that. For some big sort of moving thing that moved around the screen that had kind of mazes within mazes, or kind of things that had to slide around or rotate around, that you could have a rotating piece of a maze that shifted and so on. All completely valid. Right? Do all sorts of fun stuff like that. So let's see. One last thing I can do over here, just for my own sanity, is I want to make sure that I want to put some background in here for these. All right. And now, I forget where I left the where that extra set of colliders was. There's my edge collider. I'm going to turn that one off now, because I have that built in. Right. So eliminate the naive edge collider and instead use this tile map. So I could then go and use my tile map that had rocks on, and I could have certain tile maps that are things that you can see through. They could be maybe they're tagged different types of things, or they're on different layers, or everything applies here. So if we wanted to have a window that you couldn't walk through but that you could see through, you might have them on different layers so that the collisions would be enforced, but when you do your casts to see if your NPC can actually see past it, you can choose to have those be invisible or not, and so on and so on. All right. Like I said, allowing for very easy level design. Right there, we just already designed sort of our first little room in a level there. So they allow for, tile maps and palettes allow for efficient, organized use of assets. You have multiple palettes and multiple tile maps within each project and scene. Each tile map can have its own tile map collider and should have a composite collider if it has lots of touching colliders, but watch out for that auto dynamic rigid body that it creates for you here. Here, this example is more a sort of a platformer type game where we're generating some levels that our little fox can wander around and jump on, and so on and so on. So, yes, tile maps can be a key tool for 2D level design. Someday you can roll your own 3D chunk system if you wanted to really do a 3D sort of tile map system as well. But for now, let's stick to the basic 2D tile maps. You can combine and use them with all sorts of colliders and triggers to provide things like your basic boundaries, actions and trigger zones, pens, or jail cells and other rooms, doors, terrain, structures, whatever you want them to. Right? Very efficient. And physics can completely apply to them. So imagine even you designed a ship and your ship was moving around and floating in water, right? Everything would wander around or bounce around. You could put springs and have them animate and rotate and all the normal stuff. Now, of course, not everything needs to be on a tile map. Things that are dynamic will be typically implemented separately, like our enemies or NPCs or players and so on. If you do have things like moving platforms, trapdoors, etc., they can be either on a tile map or not. And we already sort of looked at a little bit at the physics piece of things while having the physics colliders or the our bullets, for example, hitting the walls there. So one other thing that is a physics feature, but kind of makes sense to discuss it in terms of tile maps, I find. There's this idea of physics materials, so that certain types of materials or certain types of usually colliders or surfaces have some sort of physical characteristics to them. So physics materials are generally applied to colliders to provide physical surface characteristics to collisions. In the case of 2D, we have simple things. We have bounciness and friction. Right? So in certain cases, you might, for example, want the interaction with these walls here to be sort of particularly bouncy. You want your bullets to bounce off them. Right? So let's create an asset or a simple material here. So create, and I have where is it now? There should be physics 2D, physics 2D. There we go. Physics material 2D. It's a little tennis ball or basketball, or I don't know what. We're going to give it a high bouncy coefficient. Say 10. And we'll go back to our walls, and we'll tell it that the rigid body that we're using here, and actually the composite collider. I need to put it on both. Let's see. I hit play. It is so bouncy that things just immediately get rocketed back. It's just ridiculously bouncy. So let's tune that a little bit. So we can go to right at our physics material that we're going to call our bouncy material. We'll make it a lot less bouncy. Go back to our scene. Still pretty bouncy, right? They basically bounce off the wall with more force than they had when they went into the wall, by a factor of 2 at this point. Turn it down to 1.5 times. Right. So you can imagine I could have a tile map that had bouncy areas and another tile map that wasn't bouncy, that would just absorb forces and so on. Right, that sort of thing. Create a black hole tile kind of stuff. All right. That's the basic idea behind physics materials. That you apply something either to a rigid body or a collider that has an impact on collisions and the physics calculations. All right. I like to sneak this in every so often, get and set. Carefully controlled mechanism for accessing a class's private attributes. Just a little commercial for that. So, as we started to use 2D animations, as we started using kind of smart enemies and so on, we talked about state machines and the notion of when something might be in a patrolling state and then go to a running state or an attacking state, and so on and so on. Now, the Unity animator, remember our animator has this sort of state machine, and if you're really clever, you can use it for AI, but there's some ways to help. Kind of the basic uses of it is to help automate certain types of behaviors of animated states. So when we talk about 2D games, we often think about our characters being, say, running or walking or idling, or usually have Sonic sitting there getting upset if he's just standing still for too long and gets impatient and so on, right? Or a running animation is different than a walking animation or a climbing animation, and so on and so on, right? So we can use the animator state machine to sort of automatically help us to kind of switch between those states according to different variables. So let's talk about sprites, our sprite characters and creatures, our hero, heroine, protagonist. In most of our games, most of the ones that people design for projects 3 and 4, we have some sort of animated protagonist, usually the one controlled by the player, sometimes affected by physics, at least affected by gravity in the final project. Question is, in the second project, how much are they affected by physics? If a bullet hits them, do they get pushed back? In the case of, let's say, the asteroids game, if something explodes, do you want it to be, your ship to be pushed back out of the way, so on and so on. Right. But you may have things like, running, flying, propelling. So if you decide to push the thrusters, it should be in a propelled state. So therefore, it should be playing the animation of the engines going, that sort of thing. Right. And our NPCs, also our enemies, antagonists, creatures, inhabitants, they shouldn't just stand around doing nothing. Maybe they should be being pushed around, and they can, of course, be animated. Right? It's nice to use animations using similar techniques as we'd use to the regular player. So you could move them around with random physics. You could use AI like we talked about already, so I think I got my order of, I could get these back in order from where we were last time. So imagine starting off we need some sort of hero. I like to use from the, what's it called? The Woodland Forest, Sunnyland Forest set, this little hero here. Use that one quite a bit, but you use any of them. And you use the animator window. This is where it starts to get really interesting with the animator window. You can sort of think of it as sort of a flow chart or a state, it is a state machine. The animator is a state machine that sets animations as states that can be transitioned between according to conditions governed by certain parameters. The simplest parameters are Booleans and triggers. So imagine we have a character that starts off and we'll have an entry state. And it has certain things that it can do. It can run. I don't know why we have multiple run states in here, but we have fox run, we have fox climb, we have jump, crouch, hurt, and we have another run for some reason. I don't know why I had two runs in this one. But the idea in a state machine like this, or in this flow machine, like this, is that there's going to be potential moving from one state to another state. So you may go from a walking, that's probably what this is supposed to be. Run is probably walk. All right. So you would start off in here, you'd go to as you start to move, you'd go in a walk state, and then maybe as your speed exceeded a certain value, you go from the walk state to the run state. Right. Once you're in the run state, you could go back to the walk state, but maybe you're only, can you jump while you're running? I don't know. In this case, it looks like you can, right? Because we can go from run to jump. You'll see a little arrow here. So there is a little arrow pointing from run to jump. So that's valid. So you can go from any state to jumping. And normally, you'd see like a different number of combinations. The more you rely on, there's this kind of get out of jail free card called the any state, which means any state can then go to any of the things that it points to. So if you're in the hurt state, which you got to from any state, you can wind up coming out of the hurt state to any of the other states because any state is there. So any state's kind of a wacky thing. This one's a little confusing. The more states you have in there. I shouldn't lead with such a complicated one. So we have transitions between states. You might think, well, it's just a matter of you're either running or you're jumping, but there actually are ways to ease in between states, right? You can gradually transition between walking and running. What that means can depend. It might be a blended animation, or it might be some sort of blended skeletal animation that you can actually, you can't really blend between bitmap animations all that easily. But as you get into 3D models and things, we have certain poses, and you can do blends between poses. You can use this to have, go from a simple walk to a fast run and have sort of jog states in between as it sort of interpolates between things. So this determines how, this window determines how you transition from one state to another. The important part of these conditions down here at the bottom, when you go from running, you're going to go from the any state to run when running is set to true. And I think this is worth a demonstration here. All right. So let's jump back over to Unity again. So if we have our new scene again, scene is castle. Save. So we need a hero, and luckily we have these 2D character sprites, which is our little character here, and carrying stuff. What else do we have here? Crawling, holding. Wow, lots and lots of different states. hit, hammering. I want to find just a simple walking. So, gun, hammer, hit. Okay, idle. Idle is a good one to have. So I'm going to take the idle one, and I'm going to put it into the scene here. And automatically it's going to ask me to create an animation with that character because it noticed I tried to drag in a whole bunch of different sprites all at once. Right? So it's trying to create an animation for us here. So I'll go to this, and I'm going to create a folder called Astro Animations. Okay, and the first one is going to be idle. If I press play, our little astronaut is going to not be visible. So let's put our astro. Go ahead and put our astro on the scene. And it immediately starts playing its little idle. Oh, it has idle front, back, and side. Even more interesting. So let's go and edit that animation to kind of just use the one that we're interested in. So we're going to open the animation window, and we'll see that we can kind of scroll through here. See, there's the forward one. Then we have a side one somewhere in here. So we actually don't want any of these. I'm going to delete those. And now we'll use that. Maybe make that one shorter here. How do I set the end? I just forget here. Where's that doing the right thing? Oh, I guess it's the right thing. All right, so we have our idle animation. And we're going to do a real, or use a really quick character controller of some sort in here. And let's see what we've got lying around. We have a character controller. And, oh no, we don't use that character controller. That's the 3D character controller. We had Apple movement. Nope, that's the wrong one. Let's go back instead. Easier way to do this. We'll use the shmup controller. That's the one we want. So we'll go to Astro, and we'll drag the shmup controller, put that on our little Astro Boy. And now extra bonus action on there. Horizontal, vertical. Velocity is input axis times speed. And why was that doing that? Oh, I know it. I already left this Apple movement script on it. That's not a good thing to have there. There we go. First day back. There we go. All right. So you would think with WASD he would move. It doesn't move. Anyone want to guess why not? Lack of rigid body. So since it is using using physics for movement, we better make him move. And we'll put a capsule collider 2D on it. Tighten that up. So now it should move. Not exactly the best one, but we'll use this. It's kind of a weird one. So for our purposes, it'll be good enough. So we have it moving around, sort of just in the general idle state. And I guess because he's an astronaut, it makes sense he could move like that. But let's do more with our animations. So go back to our project. And we had our sprites. And at idle. Let's just go with a simple jump. So I'm going to create a new clip in the animation, and I'm going to call this one, let's see, assets, Astro Animations, and this one is going to be called jump. And we're going to drag in, I guess grab all of them. Bring them over here. He's jumping really, really fast. All right, that's not bad. So what I want to do is I want to say, as he moves up and down, I want him to switch to that other jumping animation. All right. So let's figure that out. So we have the animator. It has two states in it. Let's open up the controller now, and we'll be able to see the controller has, boy, I'm really real estate limited here. So here's our animator controller. We have a jump state and we have an idle state. And what I want to have happen is when his speed passes a certain value, I want it to automatically move from one to the other. Right? So I'm going to set a parameter, and I'm going to make that parameter is going to be speed. And now I'm going to say make transition from idle to jump, and I want to give it a condition for that. Right? So you see over here automatically, if I select that transition, it'll show me the conditions for that transition. Right now, list is empty. I'm going to say speed is greater than 0.1. I should go from idle to jump. Right. And I'm going to create another transition that is select that one and say, well, all right, if speed is less than 0.1 and speed is greater than negative 0.1. All right. So there's a kind of a band in there between, you know, as he's moving pretty slowly, he's going to wind up there. And here I've got that transition. I could also create a second transition to say that speed is less than negative 0.1. Right? So I have multiple ways to go from idle to jump because I have to kind of notch out that band in the middle. It's got to be greater than this or that. So because it's an or, that's why I have these sort of two possible transitions here. This one is an and, so I can just have a single transition there. So now it's a matter of saying, well, somehow I have to tell it what this speed parameter is. So to set the speed parameter, I can do that in my script. So I'll close my animation for a second, and I'm going to have a simple script on our Astro boy here. And add a component, Astro script. So inside of update, I'm going to do this the quick way. Get component animator and I have set float. The float I'm interested in setting is the one that's called speed. This is the version I'm using, the one that's can pass name. And I'm going to send the rigid body's, the magnitude of the rigid body's velocity. Or I want it to present, yeah, well, I guess I didn't have to worry about negative, did I? We'll just say, yeah, get component rigid body 2D, velocity, magnitude. So yeah, I didn't even have to worry about negative in this case, right? Our simple case. So all I'm going to do here is I'm going to say set my speed variable, speed parameter of that animator to the magnitude of my rigid body's speed or velocity. All right. And it's not quite working. Why not? Well, let's see. Let's use the debugging tools. So first off, we're going to go to the game scene, and we're going to say don't maximize on play. And let's look at our animate. Whoops, not that. Our animator. All right. Choose the Astro Kid. We can see there. There's our parameters. So if I press play, see it's in the idle state, and speed is not changing. All right, so I must have clearly done something wrong. So let's see if the console is saying anything. No. When all else fails, let's go back and look at our example here. Get component animator. Set bool. We're not using a bool here. We're using a float. Running true. What went wrong? Normally here I would see yep.
Something to do with using angular velocities in the ground like that?
It shouldn't, because my velocity should still have a magnitude. So where were we here? Well, when in doubt, let's try this. We're going to do some old-fashioned print debugging. So that should really flood our... Maybe I didn't hit save. Is that possible? Maybe that's possible. It's just going to magically work now. Yeah. All right. He's very convincingly swimming. Didn't that work out? Right? So I must not have saved. I must have just totally. So let's get rid of this print. And let's look at that shmup controller again for a second. For some reason, it like wasn't hitting 0. That was kind of an interesting thing. .2. y.2. Hmm. Well, I suppose I could cheat like this. I could just say, well, let's make this 0.25. Rather than get into debugging everything, let's go with demonstrating the basic idea behind it. Right, the moment its velocity gets greater than 0.25. Well, I guess what's happening is I didn't turn gravity off for this. So there's always gravity going down to some degree. So that's why he's always got some velocity. He's slowly falling down there. Never in 100 years, I've learned a million years is way too long, would I have thought, yeah, jumping is going to be like the total, but I really kind of like this. I'm kind of digging this. It does look like he's doing a backstroke, doesn't it? All right. So that's the basics of having a state machine, right? We have an animation state machine. It can be either in the idle state or the jumping state, the backstroke state at this point now. And the thing that controls the transition is that one parameter, our speed. Right? We can get a lot more fancy with our transitions with regards to coordinating with other state machines. We have something that says, oh, okay, once his hunger goes below a certain value, then something has to be in the hungry state, or these, the user presses, might be something as simple as user input saying, oh, he's crouching. Okay, there's a Boolean for that. Set the Boolean to crouching, or that sort of thing. So that was really the whirlwind of what I kind of wanted to introduce today, and to slowly get us all kind of back into the notion of working on this stuff again. So another thing that normally gets saved for the fourth project as well, but this is another one. If you're thinking about bigger worlds, more than one screen, right? If you actually want to follow the player around, things like that, you might need to move the camera. So I think if I haven't made it part of one of the features, there's definitely some going to be, and it might even divide into a couple of more feature points for this one. Creating our own way of following the player or directing the attention of the player to certain areas of the screen depending on kind of what's going on, moving the camera around in sort of an intelligent way, sort of cinematography sub 101, naively following the player with the camera. There's a very, very powerful asset called Cinemachine, which I don't want people to use because it's just way too powerful and does too much for you, and I'd rather you do some stuff with just basically managing a camera, so that no matter what engine you're in, or if you want to design your own really simple game engine, you can kind of create your own camera movement. The simplest, naive way, which I'll just show you right now, which is fraught with problems. Remember to, which is fraught with problems when you're using this sort of player controller, especially, is that we can do simple things like, well, we have a main camera and we have the player. So why don't I make the main camera a child of the player? So whenever the player moves, the camera will move. Right, this is the super naive version. So it's kind of interesting. But because the player is locked, or the camera is locked to the player, it has a really kind of odd feeling to it, right? The world just all rotates around the player. So you might want to do something instead, like say, well, all right, let's break that. That's not a great idea. But maybe inside of the Astro script, we do something like we have and we say camera cam1 transform dot position equals so now at least we won't rotate, but we will track the player's position. Did I remember to make it public? Who knows? I did not. And I see nothing. Anyone want to guess why? Yes. Exactly. Yeah, I've collapsed. Now I'm trying to see inside my own head, which I can't do. So I've got to fix that z coordinate. So what I really want to do is say vector 3 equals vector 3 ncos for new position, and say ncos, well, let's see, do it this way. All right, so now preserve the z position of the camera and use the rest of the position. Kind of a real-locked one-for-one sort of thing. As he drifts down, the camera will move. You can get a lot more sophisticated in terms of allow the player to move around a bit, and as it exceeds a distance from the center of the screen, then decide to move, or do some sort of easing, interpolating, and that, so really doing, more precise cinematography, cinema-like movements and things. encourage that. I always like to do things like, oh, imagine you hit a switch and you want to call the player's attention to something over here. I always remember this going on in one of the original Zelda games, and on the N64, it'd be like you hit a switch and then it would call your attention to like, oh, up here a doorway or gate just opened up. Like the camera would like swing up to that and then swing back to the player. So do all sorts of interesting things with animated cameras and whatnot. Lots of fun. So let's end there a little bit early. Think about things for your next project, and keep eyes peeled on Discord for new information, and we'll try to figure out where everybody is. So we have 5 people accounted for today, and we'll regroup on Thursday and hopefully make it worth coming outside of your dorm rooms and whatnot, and hopefully interacting with people live. So, all right, thank you very much. Any questions before I decide to? Nope? Okay. See you all on Thursday.